Okay, so this topic, conceptually, it's actually pretty difficult to understand, but to do the questions, it's actually kind of easy. So, here's what I need. I need your full attention here, because conceptually, it's quite difficult. So, anyone driving here? Yeah? Cool. All right. So, I think the hardest thing for when we were learning to drive was you got a speed limit. Yeah, right. Actually, that's exactly right. If you got a speed limit, let's say 60, the hardest thing is you kind of, say this is your speed limit. When you're kind of approaching it, you kind of get closer and closer and closer, and then your concentration laps. So you either go like too far up, or then you wanna like slow down. Then you go too slow, and then you go to speed up. And then it's just like constant battle of like trying to stay to the speed limit, but not go over, not go under. And it turns out functions as well have limits, okay? And we can think about them in a similar kind of way. We don't know what's actually happening at the limit, but we want to look at what's happening around it to understand what's actually happening at the limit. So that's the important thing. The limits of a function can be described as looking at the behavior of what's happening as x approaches a certain value. And you guys actually did that over here, okay? Josh, what numbers did you get when you filled in this table? You haven't filled it out? Who's filled this out for me?
I got it.
Yeah, Jesse, shout them out.
2.5.
Yep, 2.5.
2.99.
2.99. Yep.
Skip the one.
Yep.
3.001.
Cool.
And then 3.5.
3.5. Okay. So, I left a gap here intentionally because you can see these numbers, as x approaches 1, you can see it's coming in from both sides. It's coming up, all right, from smaller values and coming down from larger values. As it's approaching 1, what's happening to y?
0.
It's getting really close to what?
0. Oh no. It's getting really close to 3.
3? Yep.
But it would not run. It goes past 3 because 3 is the limit.
Okay. No. So here's where we have to be careful, okay? For this, it actually, this line here, this is just a line y equals to x plus 2. That intersects at 3, okay? That passes through 3. And the way we describe the situation, as my x values approach 1. So as my x values approach 1, what happens to my y? My y approaches 3. Right. And so we can describe that using this definition here. All I would say is the limit as x approaches 1, f of x, well, what's the limit? The limit is 3. Okay. That's how I describe what's happening here. Okay. So I said that.
But the limit isn't 3, it goes over. So.
Okay. So hold on. This is where we have to clarify.
But it goes down from the top. Yeah.
Okay. The limit isn't the sense that it can't be equal, it can't cross or anything. In this case here, this function, all you want to look at is what's happening to x, what's happening to the function as my x approaches something. Okay. There are 2 steps you want to take when we're trying to find the limit. Hopefully conceptually that makes sense, right? Again, just to reiterate, what happens to your y values as something happens to your x values. That's the whole idea with the limit. Okay. And this is why I say it's really easy, Mitch. It's really easy to actually do the questions. Because when you're solving them, there are 2 things you want to try. The first thing is you just want to try substituting what x is equal or what x is approaching and see what you get. Okay, so it's limit of x approaches 3 for this function here, 2x minus 4. Just wait. For 2x minus 4, what do you have to do? Just try to substitute. Try to substitute x equals to 3. See what you get. But you would just get 2
minus 4 equals 2.
Yeah. Okay, so the limit of x approaching 3 for this function would just be 2, right? And we can graph that up, and we would see that as your x values approach 3 for this graph, your y values would approach 2. What's this definition saying? It's saying that, yeah, as x approaches 3, what's happening to your function? Right, okay, so this would equal to, what did you get, Jesse? So 3 squared plus 3, which equals to 12. So as x is approaching 3, our y values, just this in 11, our y values are approaching. There are 2 kind of main methods we want to look at. These are the easy types of questions. This is why I said, yeah, practically you can do these questions, you're just substituting some values. But conceptually, you want to think about what's actually happening, because when you get to something like this, it gets a little bit trickier.
Isn't it just 0?
Well, let's see. First, you want to try substitute. Let's try substitute. What would you get?
It's 0.
Well, you get 0 plus 0 over 0. Can you put that in your calculator for me? What did you get, Nathan?
7 on the money. Math error.
Math error, okay?
Oh, Muggy, so that's the answer.
So we can't do that. We can't do that. That's bad.
Bad.
That's bad. 0 over 0 is bad. What are we going to do next? We want to try another method, our different method. So we want to try factorize this expression first, okay? So what can you see that's in common on the top here? X, right, Mitch? Nick, you right, mate?
Yeah, I'm just getting changed.
X bracket X plus 4.
Good. Can we simplify? Can we simplify that?
X and X.
So, year 11, just watching here? Let's divide through. Let's divide through. And now that we've factorized, then we want to try substitute. We want to come back and try substitute then. And you can see that this will actually work out because you'll get 0 plus 4, which is just... So, what are these words saying again? So as x approaches 0, yeah.
Y will be 4.
Okay. I want to graph these in a second, but let me just give you a few more examples for you to try yourself.
Yes.
We have this function here, and you guys could do this question really easily, right? We just factorize and then substitute it. But can we understand, let's try and understand what's actually happening. You're saying as x is approaching 0, right? What's happening to your function? Well, your function is approaching... Wait, that's not right. Don't write it down.
That's right.
That's wrong.
Sorry?
Oh, no. Minus 4.
Thanks, sir.
There's another Cut it out on YouTube, quick.
So you didn't put the plus 2 there now.
So,
I'm doing that as just like.
so what's happening? So as x is approaching 0, what's happening to your y values? They're coming to...
4.
Yeah, right. So when we looked at our line, as our x values got closer and closer to 0, our y values are also getting closer and closer to 4. And you know that this is this line. Why does something that complicated like that look like a line? Mitch? Guys, just watching?
Oh, there's no one.
Why does something as complicated as that look like something that we're so familiar with? Well, there's actually a slight difference. There's a value that x can't have. And what is that value? Well, if I keep going, when x equals to 0, so that's this guy here, and I'm getting closer and closer to 0, what happens to it? Oh, can you guys see what
Undefined.
Undefined, right? Why is that? Well, because if x equals to 0, what do I get? I get 0 over 0. But what happens when you put that in your calculator, Nathan? What did you get? You got a math error. Yeah, so the function doesn't actually exist at x equal to 0. And that's why I said we have to look at what's happening around it. What's happening around it to look at what's going to happen here. And that's our limit.
Can you zoom in really close to that?
You can try.
The limit does not exist.
But it doesn't actually exist there. So there should be a hole there.
They go like microscopic like.
Yeah. I don't think that's going to help at all.
No, like that movie of the Ant-Man movie. When he goes into space and
You guys can see it doesn't exist there,
You've
right?
seen it, so don't
No, I can't see that.
There's a hole there.
So you have to go closer.
Okay. Let's have a quick look at these ones. Natasha, how did you start us off with this one?
Factorize.
Good. Yeah, that's it.
I can't factorize that.
X plus 2.
Oh, we get it.
Oh, actually, I should have said first. We would try substitute in, but we wouldn't get any. We would get a 0 over 0.
You get
Oh, we would get something else.
No, you get something.
You get something
Something
else.
over 0.
We get something over 0. That's bad. And then we'll keep going. Okay. We can simplify this out.
Hey, that's what I wrote.
Okay, and then you just need to substitute. If you're finding the limit, you can just substitute, and you should get 1. Okay. Nathan, next one for me. Yeah.
So you factorize the top.
Yeah.
It is bracket x plus 1 bracket.
Good.
Then bracket x minus 1.
Okay. And then you simplify through, you divide through, and then you can just substitute really
That's
easily.
called complaining this way. Difference of two squares, isn't it?
Any questions about this one?
Is that the difference? Yeah, that's right.